In this section, we'll learn how to factor trinomials whose leading coefficient is 1, and also solve quadratic equations by factoring. The first thing that we need to talk about is what a quadratic function is, and it is a nonlinear function. So what that means is that this time when you graph, we're not going to be getting straight lines anymore. So a nonlinear function written in the form y equals ax squared plus bx plus c. So if you remember, linear functions can be written in slope-intercept form, which was y equals mx plus b. They also could be written in standard form, ax plus by equals c. There was another form called point-slope form that we didn't learn, but there's a third way. So there's 3 ways to write linear functions. This is the only way to write a quadratic function. There's one restriction, and it's that a cannot equal 0. Because if a was 0, then 0 times x squared wouldn't be there, and what you'd be left with, bx plus c, is actually just a linear function. So the thing that makes it nonlinear is the x squared component. In 9.4, we factored using the GCF, which was essentially undistributing, which meant you could check your answer by distributing. Today, we're going to be factoring trinomials, like x squared plus 11x plus 18, and that's the answer that you get after foiling. So today, we're essentially going to be unfoiling, which means that you can check your answer by foiling. For this section, a needs to be 1, and that's in reference to the a here, that's the coefficient of x squared. So the coefficient of x squared right now always needs to be 1. Eventually we'll learn how to do it when a is not 1, but not yet. So for this first example, a is 1, because there's really an imaginary 1 right there. And we're going to unfoil this. So it's going to be x plus something times x plus something. Now the formula, we don't really use a formula a lot for this. But if you did, it would say that to do this, you make it x plus p times x plus q, and p and q must first multiply to get c, so they have to be factors of c, and then after they multiply to get c, they must also add to b. But what's really important is that they multiply to get c first. So in this problem, c is 18. I'm just matching up with up here, ax squared plus bx plus c. So c is 18. So the first thing I have to find is 2 numbers that can multiply to get 18. So to do that, I can list the factors of 18, which are 18 and 1, 6 and 3, 2 and 9. So these are the only numbers I can choose from because these are the only numbers that could go in these slots that will multiply to get 18. But then I also have to find not just those numbers, they also have to add to b, which is the coefficient of x, and in this case, that's 11. So 18 and 1 add to 19, 6 and 3 add to 9, so my answer must be 2 and 9, because those multiply to get 18 and they add to 11. Now another way to write this answer would be to reverse, which is totally fine. X plus 9 times x plus 2. And you would check your answer by foiling. So first, x times x is x squared. Outer is 9x, inner is 2x, which adds to 11x. 2 times 9 is 18. So on this next one, x squared plus 3x plus 2, I know that it has to be x and x. So my 2 numbers, here and here, have to be numbers that multiply to get 2, but add to get 3. That's pretty easy. 2 times 1 is 2, and 2 plus 1 is 3. Good to go. Pause the video, try the next 5 on your own. Be careful when you get to numbers like here and here that these negative signs are also included and they're part of your answer. Check your answer by foiling or making sure that the 2 numbers first multiply to get c, but also add to get b. So in this example, I need 2 numbers that multiply to get 10, 5 and 2, that also add to 7. So 5 and 2, 5 times 2 is 10, 5 plus 2 is 7. Here, my 2 numbers need to multiply to get 14, but also add to 9, so I would use 7 and 2. So t plus 7 times t plus 2. 2 numbers that multiply to get 12, but add to 8, 6 and 2, so x plus 6 times x plus 2. Here I need 2 numbers that multiply to get negative 20, but add to positive 1, because there's really that invisible positive 1 in front of t. So that would be 5 and negative 4. 5 times negative 4 is negative 20, but 5 plus negative 4 is positive 1. If I had accidentally reversed them, t minus 5 and t plus 4, the problem would be that they would still multiply to get negative 20, but when I add them, I would get negative 1 by mistake. So I know that that's not right. And then on this last one, two numbers that multiply to get positive 8, but add to a negative. So to multiply to get a positive but add to a negative, I need two negatives, and my answer would be n minus 4 and n minus 2. Negative 4 times negative 2 is positive 8. Negative 4 plus negative 2 is negative 6. Try these 5 really quickly. Pause the video, press play when you're ready to check your answer. So go ahead and check your answers. Make sure that if you have something different, like if you don't have y plus 5 times y minus 3, make sure you not only multiply these two numbers to get negative 15, but that when you add them, you get positive 2. You should be checking that for each. Multiply to get c, add to get b. Multiply to get c, add to get b. Check that each time. Multiplication has to happen first, the adding comes second. So the only difference on this type of example is that now after we factor, we're also going to solve. We know we're solving 1 because it says to solve, and 2 because we have our equals 0. So because this example already equals 0, I'm ready to factor. So I'm looking for factors of negative 18 that add to positive 3. And so that would be positive 6 and negative 3. Then I bring down my equals 0. And now I apply the zero product property, which says that if this times this equals 0, then one of these two quantities must equal 0. So the values of x that would make that happen are negative 6 and positive 3, which are my roots or my solutions. On this next example, it doesn't equal 0 yet, so I have to start there by minusing 24 from both sides. Now that it equals 0, I'm ready to factor, and I'm finding factors of negative 24 that add to positive negative 2, which are negative 6 and 4, which make my two solutions positive 6 and negative 4. Pause the video, try this example, press play when you're ready to check your answer. So first you have to minus 28 to make it equal 0. Then you factor by finding the factors of negative 28 that add to negative 3. And your final answers, your roots or your solutions, are 7 and negative 4. In this problem, it says that we're making banners and that each banner requires 16.5 square feet of felt. So the fact that it's square feet is telling me that I'm finding area. So if I want to find the area of just one of my banners, I first need to find the area of a rectangle and the area of a triangle. So rectangle is base times height, which in this case would be w times 4, or 4w. And then I'm going to add that to the area of the triangle, which is half base times height. And the base is w, and the height is also w. So I'm going to have half w squared. And that takes 16.5 square feet of felt. But this is only for the area of one banner, and this is the area of one banner, and I have 2. So I'm actually just going to take the entire equation and multiply by 2, which would get me 8w plus 1w squared, because 2 times 1/2 is 1, and then equals 33. So by doubling everything, it worked out because I got rid of the fraction and I got rid of the decimal. Now I need it to equal 0, not 33, so I'm going to subtract 33, but I'm also going to rewrite this equation in descending order, highest to lowest exponent. So w squared plus 8w minus 33 equals 0, and now I'm going to factor, which would be w plus 11 times w minus 3 equals 0. So w could be negative 11, or w could equal 3. But the problem here is w stands for the width. So it wouldn't make sense that the width could be negative 11 feet, because width can't be negative. So the only answer that actually makes sense in this problem is 3. Both of these numbers, if I replace w with either negative 11 or 3, both are roots because they'll both make it equal 0. It's just that in this example, negative 11 doesn't make sense, so I don't include it. Try this example, set up an equation, make it equal 0, factor, and solve. Pause the video, press play when you're ready to check your answer. So first, to find the area of a rectangle, you do base times height. The height is w, or length times width. The entire length, if this is w plus 2 plus another 2, would be w plus 4, and equals 117. You would distribute your w to get w squared plus 4w, and you can also minus 117 to make it equal 0. It factors into w plus 13 times w minus 9, which makes these your two solutions, which would both work. If you replace w with negative 13 or 9, you will get 0, but the width can't be negative. So your final answer is that the width is 9. So in these examples, if you remember back on the first slide, it said that in order to factor right now, a needs to be 1, the coefficient of x squared. Here, a is negative 1. So we're going to start by making a 1 by factoring out a GCF of negative 1. So I'm going to factor out negative 1, and I'm going to rewrite my new trinomial, which would be x squared plus 6x plus 5. And I know this is correct because if I distribute negative 1, I would get this back. Now I'm going to keep my negative 1, and I'm going to factor what I have in red the way I've been doing all along, which is finding the factors of c, which is 5, that add to b, which is 6. The final answer includes the negative sign out front, because if you distribute, or if you FOIL this, you would only get this. You would still need to distribute that negative 1 to get back the original. So make sure all those components are part of your answer. Try the next 3. Pause the video, press play when you're ready to check your answer. So over here, you factor out your negative 1, you get your new trinomial. A lot of people try to skip this step. I would not recommend it. So that way you're making sure you're looking at the sign of the right numbers and not the original signs, because they do change. So negative 1 times x plus 3 times x plus 1. Negative 1 times x plus 10 times x minus 7. And negative 1 times x minus 8 times x minus 9. Now in this example, a right now, which is strange because the variable is a, but by a I really mean the coefficient of the squared, is 2, and I need that to be 1. But if you notice, they're all divisible by 2. So I'm still going to take out a GCF. I'm just going to take out a GCF of 2. And then I'm left with a squared plus 6a plus 8. So then I keep my 2, and I factor my new trinomial by finding the factors of 8 that add to 6. 2 times a plus 4 times a plus 2. And again, the 2 needs to be here, because if you FOIL a plus 4 and a plus 2, you don't get back to this. You would only get back this piece. You still need to distribute the 2 to get that. Pause the video, try the next 3, check your answer when you're ready to, press play when you're ready to check your answer. So in this example, you can factor out a 3, which leaves you with x squared plus 8x minus 48. Again, make sure you're rewriting the new trinomial this line, so that way you're looking at the numbers 8 and negative 48 and not the original numbers, so that you're looking for the right combinations. Final answer of 3 times x plus 12 times x minus 4. Here your GCF is 4, final answer of 4 times x minus 3 times x minus 7. And here you need to make sure you take out a negative 2, so that becomes positive, which also changes the sign of the other items as well. Negative 2 times x plus 3 times x plus 2.